கேக்குதாப்பா?
கேக்குதுங்க மேம். ஒரு நிமிஷங்க.
ஓகேப்பா.
பொன்னி லாகின்ல வந்திருக்கீங்களா? ஹலோ. ஹலோ லதா மேம்.
இப்ப வருதாப்பா?
ஓகேங்கா. ஓகே.
ஓகேப்பா.
Lata ma'am, we have made you as host. Kindly check whether you can share your screen, ma'am.
Lata ma'am, shall we start the session, ma'am?
Ma'am, 1 minute, ma'am. I'll check whether the screen has been shared.
Okay, ma'am.
Yes, ma'am. It is now visible.
Okay, ma'am. Okay, ma'am. We'll start.
Shall we start the session, ma'am?
Sure, ma'am.
So participants, the current session is about key challenges of deep learning and big data, which will be handled by Dr. Lata Choti ma'am. So let's have a quick intro about our guest speaker. Dr. Lata Choti ma'am has finished her B in Computer Science and Engineering from GCT in Coimbatore, and she also completed her Masters from KSTCT in Computer Science and Engineering. She also been awarded with PhD for the title Performance Analysis of Fingerprint Face Feature Matching using Agglomerative Clustering Algorithm from Anna University, Chennai in the year 2016. She also published papers in 17 international journals and also presented around 35 papers in national and international conferences. She attended around 50 workshops, seminars, and FTPs in various engineering colleges and organizations. She delivered around 10 lectures in data mining, data structures, design and analysis of algorithms, big data analytics, biometrics, etc., in reputed institutions. She also organized around 15 workshops, seminars, FTPs, conferences, and she wrote 4 books in the field of computer science and engineering. She has completed 6 courses in NPTEL along with 3 gold medals. So now I request Lata Choti ma'am to take over the session. Ma'am?
Yes, ma'am. Thank you. Am I audible, ma'am?
Yes, ma'am. You're audible, ma'am.
Okay, ma'am. Thank you. Thank you. Good afternoon to all of you. Before I begin my topic, I'd like to thank you, our Secretary and Correspondent, S.D. Chandrasekhar sir, our Principal, Dr. N. Jayaraman sir, our Deans, Professor L. Peter Stanley Bebington, Dean Academics, Professor P. Jayachandra, Dean Student Affairs, and HOD of IT Department, Dr. V.K. Manavala Sundaram sir, and the organizers of this sttp for giving me a wonderful opportunity to handle a session in AICT-sponsored sttp on deep learning application and challenges in big data analytics. Before going into today's, that is in this topic, that is key challenges of deep learning and big data, and that is on its various applications, let us differentiate some of the closely related terms and concepts of deep learning. Artificial intelligence, machine learning, deep learning, and neural networks. These terms are sometimes used interchangeably, but they do not refer to the same thing. Artificial intelligence, it is a branch of computer science dealing with the simulation of intelligent behavior. Actually, this AI systems will typically demonstrate the behaviors associated with human intelligence, such as planning, learning, reasoning, problem solving, knowledge representation, perception, motion, and manipulation, and to a lesser extent, social intelligence and its creativity. This machine learning is a subset of AI that uses computer algorithms to analyze data and make intelligent decisions based on what it has learned without being explicitly programmed. Actually, these machine learning algorithms are trained with larger sets of data, and they learn from examples. They do not follow rule-based algorithms. Machine learning is what enables the machines to solve the problems on their own and make accurate predictions using the provided data. Next is deep learning. It is a specialized subset of machine learning that uses layered neural networks to simulate human decision making. And this deep learning algorithms can label and categorize the information and identify the patterns. It is what enables the AI systems to continuously learn on the job and improve the quality and the accuracy of results, and by determining whether the decisions were correct. And this artificial neural networks, often referred to simply as neural networks, take inspiration from biological neural networks, although they work quite a bit differently. Actually, a neural network in AI is a collection of small computing units called neurons that take incoming data, and are the reason that deep learning algorithms becomes more efficient as the data set increases in volume, as opposed to other machine learning algorithms that may plateau as the data increases. There is one more differentiation that is important to understand, that is between artificial intelligence and data science. Data science is the process and method for extracting knowledge and insights from large volumes of disparate data. It is an interdisciplinary field involving mathematics, statistical analysis, data visualization, machine learning, and more. It is what makes it possible for user to appropriate information, see patterns, find meaning from large volumes of data, and it is used to make decisions that drive the business. Data science can use many of the AI techniques to derive insight from data. For example, it could use machine learning algorithms and even deep learning models to extract meaning and draw inferences from data. There is some intersection between AI and data science, but one is not a subset of the other, actually. Rather, data science is a broad term that encompasses the entire data processing methodology. Well, actually, this AI includes everything that allows computers to learn how to solve the problems and make intelligent decisions. Both AI and data science can involve the use of big data, that is significantly large volumes of data. So now coming to today's topic, this big data analytics and data, that is, and deep learning are the two high focus of data science. Big data has become important as many organizations, both public as well as private, have been collecting massive amounts of information, which may be domain specific and contain useful information about problems such as national intelligence, cybersecurity, fraud detection, marketing, and medical informatics. Actually, this deep learning algorithms extract a high-level complex abstraction as data representations through a hierarchical learning process. A key benefit of deep learning is the analysis and learning of a massive amount of unsupervised data, making it as a valuable tool for big data analytics, where new data is largely unlabeled and uncategorized. Actually, deep learning is an AI function that mimics the workings of the human brain in processing data for use in detecting objects, recognizing the speech, translating the languages, and making the decisions. Deep learning is a subset of machine learning in artificial intelligence that uses complex hierarchical neural networks and lots of precise data to make machines capable of learning things in a similar yet in a cruder way that human can learn. The market value of deep learning software is projected to grow up to $20 million in 2000. It has been predicted up to $20 million in 2018, which and it is expected up to 2020 and in 2025 up to $930 million. Actually, from Siri's and Cortana's to Google Photos, from Grammarly to Spotify's music recommendations are all powered by deep learning. These are just a few, some of the examples of how deep in our life this, that is the deep learning has come. Next is big data. It is a data which is of huge size. Big data is the term used to describe a collection of data that is huge in volume and yet growing exponentially with time. In short, such data is so large and complex that none of the traditional data management tools are able to store it or process it efficiently. Actually, there are 3 V's in big data, mainly 3 V's. First one is volume, second one is velocity, third one is variety. Volume actually refers to the huge amount of data process and huge amount of data. Actually, this process the high volumes of low density unstructured data. This can be data of unknown values such as Twitter data feeds or click streams on a web page or a mobile app or a sensor enabled equipment and so on. For some organizations, this might be tens of terabytes of data. And next is velocity. Velocity is the rate at which the data is received and actually it is acted, and perhaps it is how fast it is actually acted upon. And then some internet-enabled smart products operate in real time or nearly real time, and it will require real-time evaluation and action. And the next one is variety, refers to the types of data that are available. Traditional data types were structured and it gets fit nearly to the relational database, in a relational database. But now with the rise of the big data, data comes as an unstructured and the semi-structured manner, such as text, audio, video, which requires additional pre-processing to derive meaningful information. Next is how this deep learning and big data gets related. The concept of deep learning is to dig large volumes of data to automatically identify the patterns and extract the features from complex unsupervised data without the involvement of human, which makes it as an important tool for big data analytics. Okay. We have seen what is machine learning, what is deep learning, what is big data, and what are this what is the current trend of deep learning and then big data. Actually, we know that with great power comes with the great responsibilities. The same way, with great technological advances, there comes the complex difficulties and hurdles. So we'll see some of the challenges of deep learning now. First one is quality and quantity of data in deep learning. Actually, this we humans can learn abstract broad relationship between different concepts and make decisions with little information. In contrast, deep learning algorithms are narrow in their capabilities and need precise information. Lots of information are needed to do their job. This is where the big data comes in. This deep learning algorithms are trained to learn progressively using data. Deep learning works best when it has lot of quality data available to it. And this performance grows as the data availability grows. A good analogy is the human brain. As human brain needs lot of expressions, lot of experiences to learn and deduce information that is analogous to the artificial neural network, which requires the more amount of data. Next, we might ask, okay, how much data is actually enough to train my algorithm? Is there any guesses? Actually, we cannot predict that. This is a question that is most frequently asked by anyone who works with deep learning algorithms. There is no actually straightforward answer, unfortunately, but as a the data scientists say that a more powerful abstraction you want, then you require more amount of data. Okay. In the case of actually this neural networks, the amount of data needed for training will be much higher compared to other machine learning algorithms. The reason is that the task of deep learning is two-folded. One is that is the first one is you have to learn about the domain and only we can solve the problem. Next one is once we know the domain, we have to train that particular system. That is when the training begins, the algorithm starts, it has to start from the scratch. So to learn about a domain, the algorithm needs a huge number of parameters to tune and play around with. For example, a speech recognition program, which requires data from multiple dialects, demographics, and time scales. Researchers feed those terabytes of data, some terabytes of data for the algorithm to learn a single language. This is a time-consuming process and requires tremendous data processing capabilities. To some extent, the scope of solving a problem through deep learning is subject to availability of huge corpus of data it would train on. Next is there is about this quality breach. Actually, the complexity of a neural networks can be expressed through the number of parameters. In case of deep neural networks, this number can be in the range of millions, tens of millions, and in some cases even in hundreds of millions also. However, when enough quality data simply isn't fed into a deep learning system, it can fail quite badly. For example, in a story that emerged during this 2017, actually the researchers fooled the Google deep learning system into making errors after altering the available data by adding only some amount of noise. While the errors are forcefully unearthed by the researchers related to trivial matters such as mistaking rifles for turtles in image recognition algorithms, this still exemplifies the dependence of deep learning on the right quality and the quantity of data for it to work accurately. With small input variations in data quality, having such profound results on outcomes and predictions, there is a real need to ensure greater stability and accuracy in deep learning. Furthermore, in some industries such as industrial applications, sufficient data um, might not be available, limiting the deep learning adoption. Okay, next challenge is the security of data that has been used in deep learning. Deep learning needs to train and retrain on massive realistic data sets. And during the process of developing an algorithm, that data needs to be transferred, stored, and handled securely. But when a deep learning algorithm is deployed in a mission critical environment, attackers can affect the output of the neural network by making small malicious changes to inputs. Now, let me explain that simply with an example. Let us consider the self-driving cars. Actually, the self-driving vehicles are partially powered by means of this deep learning. If one was to access the deep learning model, that is, if one intruder can be able to access the deep learning model and make certain input alterations, what will happen? The vehicle behavior could potentially be controlled in a malicious manner. That is, the smallest variations in the input data can lead to drastically different results, making them inherently unstable. Some other examples you can tell that is a change in the financial outcomes, result in the wrong patient diagnosis, and so on. Next is the next deep learning challenge is the difficulty with the changing context. Actually, when a neural network model is trained on a certain problem, it will find it difficult to answer very similar problems presented in a different context. This is one of the challenge in deep learning. For example, if a deep learning system which can effectively detect a set of images can be stumped when presented by the same images rotated or with different characteristics. For example, instead of providing the grayscale image, if I provide the color image, or instead of there is a, even if we change the resolution of the image, that itself will affect the output. That is the final result. With an increased demand for real-time local data analysis, for example, from IoT devices, the time to quickly retrain this deep learning models to understand new information may not be sufficient to keep up with the pace of this data inflow. So this actually there's a Google's DeepMind's research scientist Raja Hansel states that there is no neural network in the world and no method right now that can be trained to identify the objects and images that is which can play this space invaders and listen to music and so on. This simple task can also be cannot be done perfectly with a small change in the input. Then this has become a big challenge. Next challenge is the neural networks are acting as the black boxes. That is, what is actually this black box? While this decisions are made by rule-based software, which can be traced back to the last, and if and else the same can't be said about the machine learning and deep learning algorithms. This lack of transparency in deep learning is what we call the black box problem. We'll see what is the black box problem now. We know our model parameters, the data fed to the neural networks and the way they are put together. But we usually do not understand how they arrive at the particular solution. Thus, neural networks are essentially black boxes because we don't know the exactly how we get the particular solution. Just like in human brain, the reasoning of a neural network is embedded in the behavior of thousands of simulated neurons arranged into dozens or even hundreds of interconnected layers. Hence, it is impossible to look inside of it to see how it works. The decisions the deep learning models make based on these findings often confound even to the engineers who created them. This might not be a problem when deep learning is performed. When deep learning is performing a trivial task, where a wrong decision will cause little or no damage. But when it is deciding the fate of a defendant in court or the medical treatment of a patient, mistakes can have more severe repercussions. So actually, this transparency issue it is still unsolved is a potential liability when using deep learning for problem domains like financial trades or medical diagnosis, in which human users might like to understand how a given system made a given decision. Although there have been some developments in neural network technology which had enabled the creation of neural networks that can explain themselves, this gaining transparency into deep learning networks is a huge challenge that rests on the advancement of various techniques that help us to visualize the features represented by individual neurons. Now we have seen some of the challenges of this deep learning. We'll see some of the challenges of big data also. First one is that there is actually this data professionals should have to know. That is the first and foremost one is the lack of understanding of big data. That is the data professionals who are using the big data must know the importance of data. But employees in a company may not know what the data is, how it has been stored, how it has been processed, the importance and the sources where the data has been retrieved. So there is a possibility that they may not keep the backup of sensitive data. They might not use the databases properly for storage. As a result, when this important data is required, it cannot be retrieved easily. To overcome this, big data workshops and seminars must be held at companies for everyone. That is, who is going to handle the data. Basic training programs must be arranged for all the employees who are handling the data regularly and are a part of this big data projects. The next challenge in this big data is the data growth. One of the most important challenge of big data is storing of this huge sets of data properly. The amount of data being stored in data centers and databases of companies is increasing rapidly. As these data sets grow exponentially with time, it gets extremely difficult to handle this. Also, most of the data is unstructured and comes from documents, videos, audios, text files, and other sources which cannot be stored in the case of a that is a which cannot be stored in normal databases. To handle these large data sets, companies are opting for modern techniques such as compression technique, tiering, deduplication, etc. Actually, what is compression is you're going to reduce the number of bits in the data, thus reducing its overall size. And then the deduplication is actually the process of removing the duplicate and unwanted data from the data set. Data tiering is nothing but it allows the companies to store the data in different storage tiers. That means it ensures the data is residing in the most appropriate storage space. Data tiers can be a public cloud or a private cloud and flash storage, etc., depending on the data size and the importance of the data. Actually, these companies are also opting for big data tools, which can be the Hadoop, NoSQL, and then other technologies also. Okay. So coming to this big data tools, next challenge is which tool has to be chosen for our application. Actually, these companies often gets confused while selecting the best tool for big data analysis and storage. Is Hadoop or MapReduce or this path, which one is good enough for data analytics and storage? That is a big question mark. These questions are sometimes cannot be answered. They end up making poor decisions and selecting an inappropriate technology. As a result, money, time, and the more efforts and the working hours are all become wasted. Okay, so the best way to overcome this challenge is to hire the experienced professionals who know much more about these tools. Another way is to go for big data consulting. Here, the consultants will give a recommendation of the best tools based on your company's scenario. Next challenge is the lack of data professionals. Actually, to use this big data tools, companies need skilled data professionals. These professionals will include data scientists, he can be a data analyst or the data engineers, who must be experienced in working with the tools and making sense out of this huge data sets. Companies face a problem on lack of big data professionals. In order to bridge this gap, companies are investing more money in the recruitment of skilled professionals. They also have to offer training programs to the existing staff to get the most out of the to get the most to get extract most of them. Another important step is the purchase of data analytics solutions that are powered by artificial intelligence or machine learning. These tools can be run by professionals who are not data scientist experts, but have basic knowledge on using these that is these systems. Okay. Next one is the data security, which is the primary importance, primary challenge in the case of big data. Actually, securing these huge sets of data is one of the daunting challenges of the big data. Often, companies are so busy in understanding, storing, and analyzing their data sets that they are and they push this data security for later stages. But this is actually not a smart move, as unprotected data repositories can become the breeding grounds for malicious hackers. Companies can recruit more cybersecurity professionals to protect their data. Other steps that can be taken for securing data include you can go for data encryption, data segregation, identity and access control, implementation of endpoint security, real-time security monitoring, use of big data security tools such as IBM Guardian, and so on. Next is the data integration. Actually, data in an organization comes from a variety of sources such as social media pages, ERP applications, customer logs, financial reports, emails, can be presentations and report, and then there's some of the reports, can be reports also, which is created by the employees. Actually, this combining all this data to prepare reports is a challenging task. Data integration is a crucial for analysis, reporting, and business intelligence. So it has to be perfected. And actually, this companies have to solve their data integration problems by purchasing the right tools. Some of the tools that has been in the market are Arc ESB, IBM InfoSphere, Xplenty, and then Information Power Center. And there is Clover DX, Microsoft SQL, QlikView, Oracle Data Service Integrator, and so on. So I have listed out some of the challenges in data. There is big data also. So that's all from your side. Actually, I have listed out some of the challenges in deep learning as well as this big data, and some more maybe have been missed out. Hello, ma'am. Mainavati, ma'am.
Ma'am,
actually,
for the session, ma'am.
Ma'am, I have completed, ma'am.
Ma'am, okay, ma'am. Let me ask the participants for any queries.
Okay, ma'am. Okay, ma'am.
Participants, is there any queries? If you have a query, you can ask her or just type it in the chat box.
Bye.
Ma'am, we are getting positive responses such that informative session,
Okay,
and
ma'am.
there are
Okay,
no queries, it seems, ma'am.
Okay, ma'am. Thank you, ma'am. Thank you so much.
Thank you very much for sharing your knowledge with us and being a part in our sttp series 3. Thank you once again, ma'am.
Thank you, ma'am. Thank you so much.
Okay.
Thank you, participants.